In January 2005, a unique journey began. NASA launched a probe named Deep Impact into the vast expanse of space, driven by a mission to uncover the origins of water on Earth. This probe traveled an incredible 270 million kilometers, reaching close to a comet that held secrets sought by humanity for centuries. Once again, in the videos from Legends and Lessons, we are reminded that Earth is the only place in the entire universe where humans can thrive. It feels as though Earth was tailor-made for us, with an abundance of water, food, and oxygen. Yet, our beautiful planet didn't always exist. 5 billion years ago, where Earth and our solar system are now, there was only a vast cloud of dust and gases at the edge of the Milky Way galaxy. This immense cloud, known as a molecular cloud, was filled with tiny particles of sand, silicon, and various metals, born from the remnants of ancient stars that exploded long ago. These were no ordinary clouds, but colossal structures visible through the Hubble Space Telescope, stretching across 100 light-years. Imagine a cloud so vast that it would take light itself 100 years to travel from one end to the other. A cloud 60 million times the distance between the Sun and Earth. Within this molecular cloud, gravity began its timeless dance. Particles started to attract each other, colliding and generating energy that heated the core of the cloud. Over millions of years, this process transformed the core into a massive ball of fire, our Sun. The remaining cloud material began to orbit the newborn Sun, forming the building blocks of planets and moons. The story of how our Sun and planets formed was first hypothesized by philosophers in the 1700s, but it wasn't until the advancements in telescopes in the 20th century that we could observe these cosmic nurseries. In March 2003, an experiment aboard the International Space Station provided a crucial piece of the puzzle. Astronaut Don Pettit observed salt particles clumping together in a plastic bag, mirroring how particles in space come together to form planets. Around 5 billion years ago, these clumps grew larger, driven by gravity. Once a cluster reached the size of a mountain, its gravity became strong enough to attract even more particles. Much like a cosmic vacuum cleaner, over millions of years, 20 planetary embryos emerged, orbiting the Sun. These early planets collided, merged, and grew, reducing their number but forming larger, more stable planets: Venus, Mercury, Mars, and our Earth. In its infancy, Earth was a fiery, molten mass, bombarded by solar storms that threatened its ability to support life. But Earth had a secret weapon, its molten iron core, which generated a protective magnetic field. This magnetosphere shielded the planet from harmful solar radiation, allowing it to cool and become hospitable to life. The journey from a fiery, uninhabitable world to the lush, life-sustaining planet we know today is a testament to the resilience of Earth and the power of natural forces. In the 1960s, the Apollo missions brought back moon samples, challenging previous notions about our planet's history. These discoveries revealed the dramatic collisions and cosmic events that shaped our world. Through exploration and the relentless pursuit of knowledge, we continue to uncover the profound story of our origins. It is a journey that connects us to the cosmos and reminds us of the delicate balance that sustains life on our precious Earth. In the vast, cosmic expanse of space, our planet Earth owes its existence to a series of incredible and improbable events. One of the most fascinating aspects is how the Earth's magnetic field extends millions of kilometers into space, creating a protective shield that stops harmful radiation from the Sun. This magnetic field is less at the north and south poles, allowing some radiation to enter the atmosphere and create the stunning aurora borealis and aurora australis, commonly known as the northern and southern lights. Even as Earth fought off solar storms, it faced another monumental challenge: a collision with a planet-sized body. To understand this, we need to journey back to the 1960s, when America embarked on the Apollo missions. At the time, it was believed that the moon was a fragment of Earth that separated for some unknown reason. However, when astronauts brought back samples from the moon, they found these rocks were unlike any found on Earth. They seemed burnt. Further investigation revealed that the oxygen isotopes in the moon and Earth's rocks were similar, proving that the moon was indeed a part of Earth that had been superheated. This heating could only have been caused by a cataclysmic event, the collision with another planet, almost as large as Mars, named Theia. When Theia collided with Earth, it unleashed an immense amount of energy, scattering molten debris into space. Over thousands of years, these pieces coalesced to form the moon. Initially, the moon was much closer to Earth, 15 times closer than it is today, and it has been slowly drifting away at a rate of about 1.5 inches per year. The collision with Theia not only formed the moon but also tilted Earth on its axis by 23.5 degrees, a tilt that gave our planet its diverse climates and seasons. This tilt means that different parts of Earth are closer or further from the sun at various times of the year, creating the seasons that bring us different fruits, vegetables, and weather patterns. The moon's gravitational pull also generates ocean tides, which are crucial for marine life, distributing nutrients throughout the oceans. But how did water come to be on Earth? This mystery has puzzled scientists for years. In January 2005, NASA launched the Deep Impact probe, sending it 270 million kilometers into space to study the comet Tempel 1. On July 4, 2005, a 350-kilogram copper impactor from the probe collided with Tempel 1 at a staggering speed of 38,000 kilometers per hour, creating a massive crater. This impact was captured by telescopes on the probe, revealing water in the form of ice within the comet. This discovery proved that water exists within comets in the asteroid belt far from the sun. But how did these comets reach Earth? Experts believe Jupiter, the largest planet in our solar system, played a crucial role. With its immense gravity, Jupiter can alter the orbits of comets, pulling them out of their circular paths and into elliptical orbits that intersect with Earth's path. Geologists believe that water was brought to Earth by these comets about 500 million years after the planet formed. Evidence from zircon minerals found in Earth's rocks, which require water to form and contain uranium particles used to date their age, shows that they formed around 4 billion years ago, confirming that water arrived on Earth 500 million years after its birth. The birth of Earth from a molecular cloud, the collision with Theia, the creation of the moon, and the arrival of water via comets, all these events have made life possible on our planet. As we uncover the secrets of our past, we gain a deeper appreciation for the delicate balance that sustains life on Earth. Thank you for joining us on this journey through time and space on Legends and Lessons. Your comments and shares mean the world to us. Stay tuned for more incredible stories in our next video.